Our primary goal of this experiment was to reduce costs of the filter and make it lightweight. To do this, we decided against using the housing, which at $70 we deemed to be both too expensive and too heavy for our filter. As a replacement, we decided to use a styrofoam cup, which was much cheaper at $6 and much lighter. For our two stretch goals we wanted to achieve, first, Hello Dave, which meant integrating the spectrometer as a flow-through device. Also, we wanted to use one type of media. We speculated that multiple medias would be too costly and less efficient. So, after days of testing, we decided to use solely activated charcoal for our filter.
Our filter was designed as such. It had a top layer of cheesecloth, which helped filter out some of the coloring from the water. It had a couple layers of charcoal and filter paper, and a funnel to direct the liquid throughout the filter.
With respect to our filter's performance, we were overall very, very pleased with our results as dye removal percentage increased with each iteration, and by the third iteration on the first trial, we were able to remove 43.56% of the dye. Alternatively, with each iteration, the error began to increase in our dye removal percentage readings, which is something you might want to look to improve on in the future. Additionally, we saw these same trends with our own spectrophotometer. However, due to the fact that our spectrophotometer used a green LED and the more precise spectrophotometer in the lab used red LED, which those two colors are different spectrums, which led to different absorbance values, but the same trends were recognized. Also, we also measured the average flow rate for each iteration, which decreased with each iteration, which was expected as the dye is more filtered. It takes more time because there's more resistance, which leads to less flux. So as to the cost of our filter, we had a very simple yet flawless design, which led to our final cost of a mere $139, which was spent on a cuvette holder that was 3D printed for $13 that was used to help integrate our spectrophotometer as a flow-through device. One corrugated cardboard sheet that was 1 foot square for $20, which helped our filter stand up unassisted. One styrofoam cup for $6. One 20-gram pack of granular activated carbon for $35. One sheet of cheesecloth for $15. One fine piece of filter paper for $20. Two funnels for $10, as well as one coarse piece of filter paper for $20.
So after we realized that our first iteration did not take out the red dye of the water completely, we came up with new ideas for our second iteration. One of them being paper towels. We noticed that when we dropped red food dye onto the paper towels, the red food dye separated from the pure water by a process really similar to chromatography. So we put them at the bottom of our filter, and it didn't really do anything. The second thing we tried was pre-washing the charcoal because we noticed that our filtered water came out darker than it was supposed to due to powdered charcoal left in the coarse charcoal. And that did actually help us to get the water not as dark as it was, but it was still really red. We also tried using aluminum foil to transfer the filtered water into the cuvette once it was done filtering, but it was not really feasible because it was just messy. And lastly, we tried using only charcoal to reach the stretch goal of using only one media, but that did not seem to filter out all the red dye. After realizing that some of our improvements didn't work, we decided to make new improvements for our final design. One of them being two funnels, one for directing the filtered water into the cuvette so it could flow more easily into the cuvette, and the other was holding the charcoal and directing all of the water into a concentrated area. The second thing we did was pack down our charcoal because we noticed that it would allow the red food dye to interact with the carbon molecules more, so we found that this really actually worked in filtering the red dye out. And our third design was 3D printing a cuvette holder and designing it so it would allow us to stabilize our cuvette and collect water easier. And we could also make live absorbance readings for our flow-through device. Lastly, I'd say we were pretty successful because we were able to have 23% dye removal, but there's still some things we would have liked to do differently if we had more time. Two of the things that kind of go hand in hand that we wish we could have done were filtering the water slower and having more layers of charcoal to give more time for the water to interact with the charcoal. And we also wish we could have had smaller pieces of charcoal to create more surface area that would have absorbed more dye, but not too much surface area that it wouldn't have allowed the water to flow through as easily.